Hello everyone. In this video we will see how to use foundation design module in Staad Pro. So there are two ways to open the Staad Pro Advanced Foundation. The first one is you can directly go from Staad model to foundation design module. So we will see that first. So this is a Staad building model. So analysis is completed. Then from here you can directly go to foundation design module. So I'm just clicking this foundation design. So we need to select the load cases and load combinations from this right side area using which our foundation will be designed. So I'm selecting, either you can select individual load cases and combinations, or you can select the entire uh, set of load cases and load combinations. After that you can go to Staad Foundation Advanced. So another window will get open. So initially it will ask for the license type. So I'm selecting advanced license option and then clicking OK. So Staad Foundation Advanced module will get all the support reaction and nodal node details from Staad Pro. So you can see all the node numbers here. So first step, what I will do, we will go to this loads and factors, and in the right hand side we need to define which load cases are primary load cases and which are service and strength combinations. So in this case, load case 100 to 160 is ultimate load combinations. So select those load combinations and you can select the load type here and do a batch apply, so that those combinations is changed to ultimate combinations now. And from 200 to 240, that is my service load combinations. So this is the first step we will do. Then we need to select what kind of foundation we are going to assign for each footing. So in this case, I would like to do an isolated footing for these two nodes. So I can select these three nodes and I can create a new job for isolated footing here. So in the right, once you click here, create new job, right side, the job information you need to give a name. So I'll give F1, then isolated, select the code here. So I'm selecting Indian code, IS456, unit system you can select here, and then assign to selected support. So three supports I selected, and again I need to select the load cases from here, selecting all the load cases, and then click on this create job. So you'll get a message that F1 has been successfully created. Then go to this, now you can see in the left hand side there is a new area came for isolated footing job. So here you have to give the design parameters for isolated footings. The first one is reinforcement, concrete and reinforcement. So go through this right side parameters and input all the values like grade of concrete, then minimum bar spacing, maximum bar spacing, strength of concrete, sorry, this is unit weight of concrete, then grade of steel, minimum bar size, maximum bar size, etc. The next step you need to give the soil and soil cover details. Soil and the cover details for the rebar. Then unit weight of soil, then our SPC value. So input all these parameters. Then next is footing geometry. So footing geometry, there is you can go for uniform thickness footing or sloped one. So two more options are there. You can ask program to calculate the footing dimensions, or you can set the dimension and check whether footing is safe or not. So I'm going with this calculate dimensions, and minimum length you can give. So I'll start with say 1 meter. The unit system, if you want to see, slightly come here. Yeah, minimum width 1 meter. So I'll start with 250. Maximum length say 3 meter. So these parameters you can change. So increment along x direction, z direction. So all these parameters you can input here. Then sliding overturning factors will be, these are all the default parameters. You can change if needed. Then as a final step, go to the design and then do the analysis and design. See if there is any errors or the footing sizes is not sufficient with the input values, then the design calculations will not, the calculation sheet will not get generated. So in this case, the minimum size of footing required is 1.2 meter by 1.2 meter and 250 mm thickness, and rebar required is 10 mm rebar at 200 mm center to center. And you can see all the detailed calculations below. You can just go through all the detailed calculations here. And just forgot to mention one thing. There is soil bearing factor B, which we can change here. Whenever we go with the service, whenever we go with the wind and seismic cases, there will be some permissible. We can increase the net soil bearing capacity with a factor. So those things we can change it in this area. Like if you go to the soil parameters and click on this pile or soil bearing capacity factors here on the right hand side. So wherever your service load combinations, for wind and seismic cases, you can change the factor here. So once you change that, you can again design the footing and see the factors change. Factors will get changed in the design calculations also. So detailed report we can see here the factors for the wind and seismic cases. Now it's changed here, soil bearing factors. So the pressure checks at 4 corners are mentioned here. and sliding and overturning factor checks are mentioned here. So all checks has been done based on the factor of safety which we provided here for all combinations, load combinations. So finally at the end we will get the design sketches also. So in case we would like to design an eccentric footing, there is an option here. Go to this footing geometry, and in the footing geometry there is an offset uh, area for x direction and z direction. So you can give an offset here in the say 400 mm offset, 400 mm offset in the x direction, and then you can just check, or in this case say I would like this column to be shifted here, or this is our boundary line. In that case, uh, 600 minus 230, so minus 150, so 485 mm offset is there. So I'll give an offset of 485 mm, and we can check the design again. So you can check the footing design result now. So area footing, the length and breadth is changed now.